Hey everyone, and welcome back to The Explainer. I am so excited to jump into today's session because we are unpacking something absolutely foundational. If you're currently tackling Chapter 7 of your Grade 10 Geography syllabus, Introduction to Maps, or honestly, even if you're just a massive geography nerd like me, you are in the exact right place. We're going to open up the Cartographer's Toolkit and explore the universal language of maps. I mean, maps are literally everywhere in our daily lives, right? But how much do we actually know about the science that makes them work? Well, let's find out. Okay, so here's our quick roadmap for today. We've got 6 parts. Section 1, the Universal Geographic Language. Section 2, From Tablets to Technology. Section 3, Types of Maps. Section 4, Finding Direction and Orientation. Section 5, Understanding Map Scales. And finally, Section 6, Sri Lankan Topographic Maps. All right, let's kick things off with Section 1, the Universal Geographic Language. Now, before we can even start using maps, we have to wrap our heads around a massive physical challenge. Seriously, how do we fit the huge, three-dimensional Earth onto a completely flat piece of paper? It kind of sounds like a magic trick, doesn't it? But this is exactly the puzzle that cartographers have been solving for thousands of years. Our Earth is this giant, bumpy sphere packed with mountains, deep valleys, and oceans. Flattening all of that out without distorting the truth of the landscape, that's a monumental task. It takes a very specific, universal language to translate our crazy 3D world into 2D data. And to pull off that 3D to 2D translation, we rely on a core definition. A map is a presentation of the physical and cultural features on the land according to a scale, using various techniques. There are a couple of key things to grab onto there. When we say physical and cultural features, we mean we're showing both natural stuff, like rivers and mountains, and human-made stuff, like roads and cities. And doing all of this according to a scale, well, that is the secret mathematical sauce that makes a map a scientifically accurate tool instead of just, a pretty drawing. Moving right along to Section 2, From Tablets to Technology. To really get this universal language, we have to look back at our natural human urge to map out where we live. Get this, around 5,000 years ago, someone in Mesopotamia drew a map on a clay tablet just to show their local neighborhood. That's widely considered the absolute oldest map we've ever found. Imagine having to scratch lines into wet mud just to give someone directions. Obviously, fast forward to today, and cartography has evolved from literal dirt into this highly advanced digital science. Today, we're definitely not using clay. We rely on a super powerful modern technology triad. First, we've got GPS tracking, exact coordinates from space. Yep, the exact same tech that lets your phone order food delivery right to your door. Then we have GIS, or Geographic Information Systems. These are massive computer databases that let us layer incredibly complex geographic data over one another. And finally, RS, or remote sensing, which uses satellites and aircraft to just constantly scan the Earth's surface. These 3 technologies work seamlessly together to give us that pinpoint, real-time accuracy we completely take for granted today. All right, Section 3, Types of Maps. Because our modern world is just so incredibly complex, we have to categorize our mapping tools based on what we actually need them for. Think about it. It is physically impossible to cram every single piece of geographical info onto one map. Every road, temperature shift, population center, and soil type all layered together, it would just be a messy blur. So we split them up. On one hand, we have thematic maps. These are hyper-focused. They highlight one specific theme or data set, like annual rainfall, or maybe where certain crops are grown. On the other hand, we have topographic maps. These are your heavy hitters, comprehensive, highly detailed maps that show both the physical landscape and the cultural features all together for a specific area. Which brings us to Section 4, Finding Direction and Orientation. Having a perfectly accurate map is completely useless if you have no idea which way you're facing. Setting up your map so its directions perfectly match the real world is called orienting, and it's actually pretty simple. Step 1, just lay the map completely flat. Step 2, identify where north is in the real world. You can do this super precisely with a compass or even just roughly by checking where the sun rises. Step 3, physically rotate your flat map until the printed north arrow matches the real world north you just found. Boom, your map is oriented and you're ready to go. But here is a crucial point when you're orienting. You've got to know the difference between the 2 norths. Yep, there are 2. First, we have true north. That's the static, absolute direction of the geographical North Pole at the very top of the globe. But then we have magnetic north. That's the direction your physical compass needle actually points to. because it's being pulled by the Earth's natural magnetic fields, which actually shift around a little bit over time. Cartographers always have to calculate for this difference, so we don't end up miles off course. Let's dive into Section 5, Understanding Map Scales. Okay, this is where the real math of cartography shines. Map scale is the ratio of the distance between two places on a map and the true distance between those corresponding places on the land. Without a scale, a map is honestly just a sketch. Scale is that essential ratio that lets us take a regular ruler, measure a couple of centimeters on paper, and mathematically prove that two cities are exactly 20 kilometers apart in real life. It literally scales the massive world down so it can fit right in the palm of our hands. And finally, Section 6, Sri Lankan Topographic Maps. Let's apply all this awesome global theory to something local. If you're looking at topographic maps across Sri Lanka, the exact standard scale ratio used is 1 to 50,000. So what does that actually mean for you? It means that 1 unit of measurement on that map equals 50,000 of those exact same units out in the real world. So a single centimeter on the paper represents 50,000 centimeters, which works out to 500 meters on actual Sri Lankan soil. Now check out this number, 92. You obviously can't fit the entire highly detailed landscape of Sri Lanka onto one single manageable piece of paper at a 1 to 50,000 scale. I mean, the map would be the size of a giant carpet. So what authorities did was meticulously divide the entire map of the country into 92 distinct grid divisions. If you need to study a specific region, you just look up its number and pull that exact sheet out of the 92 available. When you do grab one of those 92 map sheets, you need to be able to visually tell apart two main zones. First up is the peripheral information. This is all the stuff printed around the outer margins. Things like administrative boundaries, coordinate grids for latitudes and longitudes, the scale indicator, and the legend that explains all those little symbols. Then you have the map face information. This is the core data right in the center. It's the actual drawing of the physical mountains, the rivers, the roads, and the towns located within that specific area. Wow, we have covered a tremendous amount of ground today, right? From basic definitions all the way to the specific mapping grids of Sri Lanka. As we wrap up today's explainer, I want to leave you with a quick thought. If human beings went from scratching rough little lines on clay tablets in Mesopotamia to utilizing real-time satellite GIS and GPS in just 5,000 years, what seemingly impossible ways are we going to map our world in the next century? Are we going to navigate with 3D holograms, real-time augmented reality lenses? The future of cartography is just incredibly exciting, and it goes way beyond what's written in our textbooks. Keep wondering, keep exploring, and thank you so much for hanging out with me today on The Explainer. I'll see you next time.